Okay, so we'll just get started. So before we begin today, I just want to acknowledge the land on which I am joining from as a traditional territory and unceded territory, of the Ganegenaha Mohawk Nation. So for centuries, they have been stewards of this land, nurturing and honoring its deep connection to their culture, traditions, and spirituality. We at Climate Reality acknowledge the histories of displacement, resilience, and resistance that have brought us to this point. I'm immensely grateful to be able to be on these lands as an uninvited guest and grateful for the Indigenous peoples who have been living and working on this territory for generations. I ask you to take this moment to reflect upon the native land in which you are situated on, and you can do so by going to native-land.ca if you are unfamiliar. And I also encourage everybody to introduce themselves in the chat, sharing their name, how they are connected to Climate Reality, if at all, and where they're joining from. And so today we have a special guest with us today. So Garrett Johnson is here with us today. Yeah, one second, I'm just pulling up their bio. So this month, he is graduating from the Mohawk College Sustainable Building Technologies program and with Evolve Builders Group about the green construction leaders in Ontario. So the Evolve Builders Group focuses on climate conscious construction. He is vested in production of carbon negative installation materials from grain products, specifically from rapidly renewable resources such as hemp, straw, and a couple other things. He has lots to share about his research on insulation from these products and what it takes to get them to pilot stage of production. And also he has experience of developing a sustainable water management system for Plenty Canada, including designing and installing a rainwater harvesting system for whole house use, bringing in a Hydroloop gray water recycling unit, designing and building a universally accessible composting outhouse, and designing and installing a constructed wetland for advanced wastewater treatment. He has ideas about what he would like to speak about to gain community traction, and I'm certain others across the country would have an interest in what he has to offer as well. And so with that, I will pass it over to you.
Awesome. Thanks, Michalina. Glad to be here. Give this presentation to everybody. So I will start sharing screens without further ado. Here we go. Okay, so as Michalina said, my name is Garrett Johnson, and I work as a designer for Evolve Builders Group, and I also do some research for sustainable building materials and different techniques. And I'm going to talk about a few different approaches and technologies that can help us make our built environment more sustainable. And this is a photo of me at the Plenty Canada open house. So as a preamble, I'd like to just acknowledge that there are many issues in the building sector, and I'm going to talk about technologies and approaches that are needed to offset a lot of the negative effects of the built environment. But I was reminded recently after speaking at an event hosted by Plenty Canada and the Niagara Escarpment Biosphere Network that no amount of technology is going to fix the issue of environmental devastation that we're seeing, and probably more important will be to change our relationship to the land and to one another. And any technological solution will inevitably be a stopgap until the broader issues are healed. We can't design the line. I don't know if anybody's seen that, but these mega projects claiming sustainability aren't the answer. And I'd like to quote Dan Longboat, who spoke at that event I referenced before, who said that hurt people, and we've hurt ourselves and hurt the land, but in the process of healing the land, we can also attempt to heal ourselves. So that's just context for the rest of the presentation. So I'm originally from Alberta. I started out working as a carpenter and was moved to Montreal eventually to pursue a career in music, and ended up, when I hit 30, deciding to go back to school and do something a little bit more meaningful than building IKEA renovations in the city. So I signed up for Mohawk College and did some work there, really dove in. And that was where I met Janet from Climate Reality Project at the Plenty Canada open house. And she invited me to come speak here after we met. So I'll start off by that work that I did at Plenty Canada, where I met Janet. So I was asked by Plenty Canada to apply to a MyTex grant to develop a sustainable septic system originally. And it kind of snowballed into this much larger project involving many aspects of water and circularity and creating a sustainable approach to the overlooked aspects of water in our environments. So I'll do a summary of the systems that I designed and we installed on the campus building. So starts off, it's a net zero building. So there's solar panels on the roof. We used low carbon construction for a renovation, adding insulation outside. Inside, there's a very efficient water use, including gray water recycling to supply the toilets. And the whole house is supplied with water from rainwater collected from the roof. So there's a below ground rainwater storage tank. And the water that does end up as sewage is treated with advanced wastewater treatment from a constructed wetland, which uses biological actions to treat the water. And we also installed a composting toilet outhouse with the green roof you see on the right there. So I'll start off with the rainwater harvesting system. You can see this is a below ground tank, 5,600 liters. And again, it supplies the whole building. So potable use, toilets, everything. And there's actually a standard now that allows you to have potable use officially, called the CSA B805. So if you're interested in doing this in your own projects, you can look that up or get your local builder or engineer to cite that standard, and building officials will take it a little bit more seriously. I learned a lot about rainwater harvesting from Verge Permaculture. I highly recommend their rainwater harvesting course. These systems are great, not just for off-grid systems, but also in urban environments. They affect stormwater management on big systems, similar to how your single home solar panels can affect the larger energy grid. So there's a lag, and when stormwater reaches the sewers and helps out with municipal infrastructure. And this is the gray water recycling unit we installed there. So it takes water from the toilets, treats it, and then, takes water from the showers, treats it, and then sends it to the toilets. And that can reduce your average home use by 30% and up to 90% for commercial buildings. And this, again, is a snapshot of that advanced wastewater treatment with the constructed wetlands. So water filters through sand and rock media where plants are rooted, and those biological activities take nutrients out of the water that don't end up in groundwater. And I designed this system with River Court Engineering. And finally, we have the true and direct circularity. So this is a composting outhouse, very much inspired by the Human Manure Handbook, which I highly recommend. It's a very great book. And this system is great because it's inexpensive and simple. A lot of the other other systems, like the gray water recycling system, and even to some degree the constructed wetland, they're expensive, kind of complex, and sometimes they're more suited toward commercial and institutional situations. But you can also take that smaller approach and do something good on a affordable scale. And you can make it look nice inside. It doesn't necessarily have to be an outhouse. There's a lot of people that have these in their homes, and it doesn't have to look bad. And that helps out with a nutrient cycle. So it takes us from a situation where we're taking nutrients from the soil and essentially just dumping them into the water to something that's more of a natural cycle where we're taking nutrients from the soil, using them, and then putting them back into the soil. The building at Plenty Canada was also net zero certified. So that means that the energy being produced on site equals the energy being consumed. And this past year, the building was actually producing more energy than it was consuming. And that's largely due to the insulation that was added and the windows. So we stripped off some very old siding that was kind of falling apart, added some low carbon insulation outboard, wood fiber, and replaced all of the windows to triple pane windows. And this is more of what I'm going to talk about for the rest of the presentation. My background is mainly in building construction, and a lot of the work that I've been doing recently has been around insulation and embodied carbon in the built environment, which I'll speak about shortly. So as everybody knows, there's a housing shortage in Canada, and people are talking about building homes more quickly. You know, build more homes built faster plan in Ontario. And this obviously has to be paired with building efficient houses. Most of Ontario is heated with natural gas, and the typical home ends up releasing about 4.5 tons of CO2 per year, per household per year. So it's obviously very important to have that building envelope, the insulation around your building be very efficient to reduce that number. But there's a similar situation with the impact of building homes. So the materials that go into the house itself also have an impact, and the manufacturing processes, the raw materials extraction, all of that ends up having an impact on the environment. And that's what we call embodied carbon. So from raw material extraction, transportation, installation, demolition, end of life, that's all embodied carbon. Whereas operational carbon is what the majority of the sustainable building industry has been focused on up until fairly recently. And that's just making sure you're not burning a lot of natural gas to heat your house. But it turns out that embodied carbon can actually have a huge effect on the overall environmental sustainability of your construction projects. And it can even outweigh that operational carbon. So on the top left, you see here an Ontario code-built home heated with natural gas. And you can see that red is the operational carbon emissions, and it's quite high when you're heating with natural gas. But if you switch to a heat pump here, your emissions actually reduce to less than the emissions of your building, even with a code-built house or with a code-built house. And there was an embarrassing discovery recently where people started to realize that the well-meaning sustainable builders and people who commission them to build their houses can sometimes end up doing more harm than good, more harm than if they had just built a regular house by trying to add all of that insulation to hit those really low operational carbon targets. So adding things like foam, spray foam, particularly the pink hard rigid foam, XPS insulation, has a very high global warming impact. And you can actually end up doing, again, more harm than if you had just built a regular house and even heated it with natural gas. Very surprising. But the good news is that it's possible to use different materials and still get a very efficient house, but have a very low embodied carbon. And this chart is from Chris Magwood's talk from Boots on the Ground in 2020, and he shows that even heating with natural gas, it's possible to have a very low carbon impact. And if you heat with your house with a heat pump, have an efficient home, use those good materials, you can have a negative embodied carbon profile for the lifespan of your building. So that means you're sequestering more carbon by building. You're actually doing something good for the environment. And that happens because plants are natural sequesterers of carbon, and especially fast-growing plants like agricultural fibers. So there's a lot of talk about carbon sequestration, building machines that are solar powered to capture carbon direct from the air. Plants are already doing this, and they're creating a material as they grow that we can use and incorporate into our environments. So that carbon sequestration, taking those natural materials, processing them with renewable energy, you can actually have those negative embodied carbon profiles for the materials that you're putting into your building. You put them into your building and they stay there for as long as that building is standing. So it can stay for 100 years easily if you build right and take care of your place. And that's important because CO2 emissions have sort of a lag effect when they're emitted. Even if we stop now emitting carbon, we have all of these issues with the carbon that is already in the environment that's going to cause warming. And to truly limit the effects of climate change, we need to not only hit net zero, but a net negative carbon. So we need to be sequestering more carbon than we're producing as an entire society. And this could be a very useful, easy way to do that in the short term, to take carbon from the atmosphere and put it into our buildings. And so I'm going to talk specifically about one aspect of a home's construction, that continuous insulation. So for those who don't know, it's now a requirement in most situations to have this layer of usually foam outside of your house's framing. And this is good for building efficiency. Continuous insulation doesn't have any thermal bridging. So that's when materials are in contact with one another, they transmit heat more efficiently when they're touching. So those studs transmit more heat than that cavity insulation. So the brown there transmits heat faster than the pink. And that white foam sort of acts as a block to prevent those studs from transmitting heat inside the building more quickly. And it's good for a building, and high performance builders use a lot of this. But depending on what material you're using, you can have very different effects on that embodied carbon, those embodied carbon emissions. So you can see mineral wool, it's not great. The units are the kilograms of carbon dioxide equivalent at this certain thermal resistance. And you can see this pink foam here is incredibly high. And installing this in your home, you essentially can't install enough to justify the savings in energy that you get by having a more efficient house. So you have to choose your materials wisely. And these are the most common rigid insulations currently used today. Those are the big five. And you can see this graph here is from KPMB Architects, and you can see this sweet spot with these insulations. So this is that pink insulation here, and you can see after about R4, when you're heating with a heat pump, the more insulation you add, you're actually emitting more carbon overall just by producing this stuff. And for different materials, they act differently. So the better materials, you see that those emissions reducing, the more R value you add to your house. So it's important to choose your materials in your building. And there are some existing products that are available, and right now they're pretty much exclusively made from wood fiber. So there's a company called Gutex from Europe, Sonoclimate from Quebec, and a new company, Timber HP, that's operating out of the United States. And that's how we insulated the building at Plenty Canada. So we did a low carbon deep retrofit. So for people considering retrofitting their building to be more efficient, choose those materials. They're available. They're not significantly more expensive than the other products, and they'll actually do a positive thing for the environment. And that's how we can have a renovation that ends up being carbon negative. So that building is heated with a heat pump and has those natural carbon sequestering materials. But not to demonize forestry, but there are issues with the lumber industry, and a poorly managed forest is not necessarily carbon sequestering, and it can do harm to the environment. So there's deforestation, habitat loss, carbon emissions from decaying roots and the brush that they clear and leave on the land. And then there's all of the transportation emissions and infrastructure that goes in from taking the wood from these forests that are further and further away as we harvest all of the forest habitat nearby population centers. Transportation increases all the time, and we're increasing the use of wood that we're needing with things like mass timber, which is great. It's a great alternative to concrete and things like that for industrial buildings, institutional buildings, commercial buildings. But there are maybe better choices and better paths to go down for smaller scale situations. And we're also already creating huge amounts of biomass, biomass that's very similar to trees, so lignocellulosic fiber. Plants are made of cellulose and lignin, essentially, and that's the same whether you're talking about trees or plants, agricultural fibers. This is a report from on the Ontario Federation of Agriculture that shows that there are 3.12 million tons of harvestable agricultural crop residues available. So the crop residue is all of the biomass, all of that plant matter that we're not using. So that's like straw, corn stover, all of the offcuts from the pieces of the plant that we eat and find useful. And we can use that to build with, and we can use that to sequester carbon. And this is often cited by hemp farmers as well. Agricultural fibers can sequester significantly more carbon per acre than forestry, which is surprising. But again, those plants, those smaller plants, grow a lot faster than trees. And forests are amazing, and we should not cut down more forests, but they also drop a lot of their biomass with their leaves on the ground. And there's a lot of that CO2 that gets re-emitted into the atmosphere. So with our farming practices today, we typically take most of that 3.12 million tons of biomass and we dispose of it, and it decays and turns back into CO2. And some of that's good for the soil and we need it, but crops are such high yield these days that there's actually too much biomass produced to be able to leave it all on the ground. And there's been studies that show you can remove most of it without negatively affecting the carbon content of the soil. So we can intercept that chain of the plant growth and then put it into our buildings and sequester carbon. And there are methods already existing that use this concept. So straw bale construction, it's been around for over 100 years and is seeing a revival recently. You can make very modern, beautiful looking homes that you would never guess were made from straw bales. And there's even a growing community of builders making prefabricated straw bale wall assemblies. So Eco Cocoon from Europe is one of the big players in that field right now, as well as Croft from the United States. So they essentially pack straw bales or straw from agricultural the waste products from agriculture, and they pack it into your wall, and that acts as insulation. They can prefabricate it offsite and then ship it over and drop it in with a crane. There's also hempcrete construction or hemp lime construction, which was recently added as an appendix in the International Building Code. So for this building method, you take hemp hurd, the inner hard core of the hemp plant, after you've stripped away the fibers on the outside, and you mix it with lime, and then you create this sticky mixture and you pack it into forms, and you can layer it up and get these kind of beautiful striations there, or you can turn it into bricks and ship it to site and build up like that. And again, you can make any design that you'd like with this. They don't need to be limited to something that looks like it was built, home built, or anything like that. They can end up becoming mainstream. They can become normalized. And beyond those other building techniques, which I think will often might end up staying as niche systems, because the building industry is made up of workers and people who have skills and training, and you have to learn new skills and develop new knowledge to implement some of those other techniques. And again, those are great and they're necessary, but we can also take products that we know how to use already, like fluffy batt insulation, like that pink fiberglass you see in your walls, and we can substitute it with natural materials. So these two companies make batt insulation, so the insulation that goes in between your studs, it's fluffy and squishy. They make it out of the hemp fibers, so that outer layer of the hemp plant that I mentioned before. The inside is the hurd and the outside is bast, and they turn that into insulation. And another benefit beyond carbon sequestration for natural materials being used as insulation is that they have typically a greater mass and ability to safely store humidity in those fibers, which has a benefit that goes beyond the typical simple R value of a wall. And that's because with the heavier mass of the materials in the wall itself has to heat up before it radiates heat inside and heats your building. And it has to cool down before that coldness is felt inside your building. So the greater the thermal mass and specific heat capacity of a material, the longer it will take to heat up and cool down, and therefore the longer it'll take for you to notice those outdoor changes. That means more stable temperatures inside your house, which is great for shoulder seasons like the spring and fall, where there's a swing throughout the day and night cycle between heating and cooling. And the humidity absorption acts in a similar way. So if there's humidity within a material and it starts to heat up, it takes some of that energy to change the water's phase from a liquid to a gas. And that change happens without an increase in the material's temperature. So it kind of acts in that same way to stabilize temperatures. But where is the non-toxic, carbon negative, rigid insulation from agricultural fiber? So we saw that hemp insulation, the batt insulation, but there's not really an equivalent for rigid insulation to replace those foams that can be very harmful. And that's where my recent work has been focused. So in a project that I took on while I was in school at Mohawk College with IdeaWorks, I was sponsored by Evolve Builders Group, which is the company I work for right now, and the Canadian Bio Clean Tech Applied Research Network, CBARN. They supplied some funding and lab space for me to play around with fibers and adhesives. And originally I was very focused on hemp fiber because that insulation already exists, and it was kind of the natural inspiration. But after a conversation with Chris Magwood, who I hired as a consultant for the project, he talked about how hemp is not really grown in Ontario at the moment. And there's people growing huge amounts of other species all across the country, all across Ontario. People grow huge amounts of corn, and there's wheat across the country. Unfortunately, I'm celiac, so I didn't want to play too much with wheat straw for fear of cross-contamination. So I ended up going from that hemp bast and focusing more on the corn stover. So on the left, you can see hemp bast, on the right, that corn stover. And when you break it down, those fibers down, you end up getting something that looks very similar. The other benefit to using things like corn or wheat byproducts as something for your built environment is that you're not displacing food crops. So as a species, we end up taking things to extremes. We have that tendency to go way too far with things. And you can imagine hemp farming displacing plots of land that are close to cities that could be used for growing food. Or you can imagine people cutting down forests to grow non-food related crops. And again, we're producing huge amount of biomass already that we're not using. And the other interesting fiber that I was introduced to by the Ontario Biomass Producers Cooperative is switchgrass. So this is a perennial plant, and it establishes really deep root systems. So year after year, it keeps growing. You harvest it each year, chop it down. Next year, it grows back up again. And those root systems stay in the ground, and they add carbon to the soil while sequestering huge amounts of carbon in their leaves as well that you can take from the land without harming it. And Jamie from the OBPC, the Ontario Biomass Producers Cooperative, he was the president. He talked to me about how he was rehabilitating a plot of land that another farmer had deemed unfarmable after heavy use for growing things like tomatoes or soybeans with poor practices. And you can introduce a plant like switchgrass and rehabilitate a plot of land to make it fertile again. So the fibers were sorted out, but in the construction industry, we use a lot of really nasty adhesives. And these are the big ones that are used in pretty much every engineered building product, from plywood, particle board, insulation, like fiberglass insulation or the rock wool insulation. They're using formaldehyde adhesives with petrochemical origins, and they're toxic, or at least the base constituents are. And I really wanted to avoid these materials going into what I was developing. So that was a big part of the project. I did a lot of research, hundreds of experiments trying to create an adhesive from lignin, which is the glue that holds together plant cells. So as I said before, in every plant, there's lignin and cellulose, and they work together to create a plant. And you can extract that glue and turn it back into something that's like glue. And eventually I hit a successful formulation, waterproof, non-toxic, and bio-based. And this was the resulting sample. So these are tiny little cubes of insulation that I made. And those come from a mixture of corn stover, switchgrass, and some of the hemp fiber. And this is a larger sample. that I produced. Photographs courtesy of my partner, Simone. Another photograph of that larger sample. And we were also interested in creating something to replace OSB, inspired by this company called Planted, which is creating OSB from elephant grass. So that's another perennial plant. And this company has recently been awarded design competition awards, and they're getting money, a lot of investment to produce their materials, which is amazing. Unfortunately, it's not available in Canada, and I don't think it's even available countrywide in the States. So we were trying to come up with a similar solution here. And we produced some samples. So OSB samples from hemp hurd, that hard inner core. It's very similar to wood and those chips of wood that make up particle board and OSB, the oriented strand board, wafer board that a lot of houses use outside of the studs. And we're experimenting with a bunch of different fibers. So we see miscanthus, corn stover, another miscanthus sample, and then two on the right are hemp, and then hemp with a waterproof additive. And we're interested in developing variations on these materials. And immediately in mind, we have ideas to laminate together that insulation with the OSB and turn it into something similar to what you see on the right, the zip system, which reduces the time that buildings take to put up, because you're putting insulation and the sheathing at the same time. And we're imagining making things like particle board for cabinets, or thicker slabs for doors, or even those engineered joists you see. So that's all I've got to share with everybody here. And thanks for sticking around. I'm sure I hope it was informative. And I suppose Janet asked me to put out an ask to the community. So if there are any IP lawyers in the audience that want to help navigate patent processes, we're in that process right now, or grant writers who know about non-dilutive funding, or people who just want to get involved in the green building. I encourage you to build with your local sustainable builder, seek those alternative materials, think about your consumption, think about where your materials come from and where they go after you use them. And you can get involved in the industry. Look up videos of straw bale, hempcrete. You can change your career path if you're ever thinking about it. I did it later in life, and I'm very happy that I did. And you can feel free to send me an email. My email is there. It's garrett.johnson@evolvebuilders.ca. So thank you very much.
Thank you so much, Garrett. It was really, really nice to have this presentation. Sorry, everyone, I was a little late to join, so sorry that I wasn't able to greet you first, Garrett and Janet and all of you. But I know I learned a lot. This is taking me back into like some of my university sustainable building courses, and I'm like so excited to see all those graphs and really have that connection with the natural fibers that you were talking about. I also grew up in like rural Ontario, surrounded by cornfields, and so I was like, oh my God, perfect. Like this makes so much sense.
Yeah, they're everywhere. The whole countryside is covered in that corn.
Yeah, and I think this is like, I mean, I'd be really curious what other people think about this, and in the way that like I think intrinsically we understand how resources how much waste goes into production, and how much good use still can be, developed into things that actually still be productive, like insulation and all of this good stuff. And so I think it's really cool that people like you are actually putting those kind of thoughts that I think a lot of people have, and that like, oh, we're wasting a lot of things, we could be using our resources better, into actual like practice. It's really inspiring. It's really cool.
Yeah, thank you.
I'd be so interested to hear what other people think about that kind of thought, or if anyone else has other kind of reflections on this or questions.
I
I
see
see
a
something.
question, yeah, from Dawn in the chat. Feel free to unmute, Dawn, if you want to ask it out loud.
Yeah, for sure.
Suppose I could, but it's readable.
Yeah.
Yeah, so the question is,
I don't know, that'd be the first thing somebody probably who would tend to be skeptical about these changes would probably ask.
Yeah. So I'll address that first. So a lot of insulations other than fiberglass and stone wool that are used right now, like those foams, they're incredibly flammable. They
Mhm.
are much more flammable than natural materials.
I imagine
They're used.
they emit nasty gases when they burn too.
They also emit nasty gases. So that one of those big five insulations I talked about, the polyisocyanate, when it burns, it releases toxic gases that can permanently damage you when you're in a fire with those materials. And it's something that people often bring up. So what are the fire characteristics of the natural materials? And I often think of the story that the president of Evolve often talks about as inspiration for starting to build straw bale homes, was that his childhood house burnt down, and then he heard about how straw bale homes actually are very difficult to burn down. So the density of the materials and some of the chemical constituents, like silica that is naturally occurring in some of those harder woody fibers, they're very hard to burn. And so I've done testing on the insulation material to burn it, and it is difficult to get it to hold a flame. It'll char and smolder, but again, we're already using a lot of materials that are not only will they char and smolder, but they'll flame. And we're using these incredibly toxic fire retardants that have drastic effects on female fertility, to prevent this in spray foams and other foam insulations. And I'm not using any fire retardants in what I've been developing, and still getting better performance than what you see when you're lighting a piece of EPS on fire or something like that. And we're also using things like cellulose, like blown in cellulose. So a lot of homes will have that in their attic. That's the most common place for it. And you'll also see it in walls, and it's often a little bit denser in walls, but there are ways around that. With cellulose insulation, they treat it with boric acid, very small amount, and then it stops it from burning. And so there are approaches like that you can use to prevent the burning.
Mhm.
I see another question there. Did you have anything else to comment on, Don?
No thanks.
Or any further questions? Okay. So Jane Robertson asked, what are the barriers to building using more sustainable materials? So cost, availability. Those are both issues that end up coming up depending on your choices. I would say that there's many approaches to thinking about building sustainably. One of them could be reducing your house size by 10%. That might end up having multiple effects of reducing that embodied carbon, as well as reducing the cost, and potentially not changing your day-to-day happiness. that could make up for some of the increased costs that you might see with some of the more prominent sustainable materials that can be more expensive. But there are also ways of building more sustainably at the same cost just by thinking about those material choices. So that the cellulose insulation, it's incredibly cheap. It's just as cheap as fiberglass or something like that. And you can get cheap wood fiber board insulation that you can put outside the walls, and potentially most important is just optimizing how much concrete you're using, for example, or the orientation of your building, and things like that you can do to build sustainably on a cheaper budget. A lot of those materials I did mention, they also are often not available, which is another of Jane's questions. So if you're thinking about building and want to make some of these choices, it's good to think in advance. So if you're expecting to suddenly design something and build an enormous house in a 2-month time span, you might have difficulty. But if you're okay with waiting 4 months, you'll be totally fine. And just you talk about that in advance with your builder, and they can work it out for you. It shouldn't be an issue. Yeah, anybody else have any questions? I know I presented a lot there and kind of probably buried a lot of the water system work that I did, but yes, Janet.
Yeah, the question that I have is, when I see the hemp fibers or the corn fibers, and they're
Yep.
like all these fibers, and then we see, and I've seen in person, right, these little blocks. What are the binding agents that you use? Can you just go through that a bit? Because I heard things like we don't use this and we don't use that, but what is
Right.
it that brings those fibers down to little blocks?
So I probably can't discuss it in detail because it's part of a patent process. So I will say that they're bio-based, non-toxic, and there's a combination of a few different materials. One of them, the major ones that we're using, is lignin. So that's a byproduct of the pulp industry. So when you create paper, they're separating lignin from the cellulose, and they don't really use it for anything. And it's been a big issue. Pulp mills have been isolating it and then burning it to fuel the plants. But there's been a growing recognition that this molecule is essentially able to be substituted for a lot of reactive petrochemicals in green chemistry. So you can make things like bioplastics, adhesives, coatings, things like that. So that's the main component, and you get something like this. So this is the in-person version of those photographs I saw. So the lignin itself is brown, and that's why you get this brown color to the material.
Yeah, I was just when you were going through your presentation, I guess generally, it reminded me of earthships, and I was wondering if you knew anything about earthships and if that was any inspiration for kind of the other project that you were working on with the circular modes of sustainable buildings, I guess.
Yeah, for sure. I'm definitely familiar with earthships, and a lot of those ideas are part of the inspiration. Absolutely. Totally.
Yeah, feel free to ask your question.
Hey, thank you. Brody here. I was curious with regards to some of the materials that you're experimenting with or using. I'm curious if you had to go beyond North America to source any of these materials. I'm doing a course right now about GHG accounting and like LCAs and looking at LCIs, and so I'm thinking about that. And I have this feeling like you were too, just from the sounds of this sort of journey.
Yeah, absolutely. So with my
Sorry,
work for Evolve, yeah.
I guess, sorry if I was phrasing that question weirdly, and it was in terms of if there was any weird little kind of stories in your journey finding those materials, because like
Right.
I was here, yeah, and it sounds like you might have been going that way.
Yeah, for sure. So it was definitely difficult procuring everything. The hemp fiber I had to source from Alberta and Saskatchewan. There aren't any growers in Ontario. I think there are growers in Quebec, but I wasn't able to find them. But I was able to find a few different companies with decorticators. And that's a big hurdle that the hemp industry is facing, is that to process the plant, it's a very robust plant that is very hard on equipment. And you need this thing called a decorticator to essentially strip the outer layers of the hemp fiber from the core and be able to process it without destroying conventional equipment. And these decorticators cost hundreds of thousands or millions of dollars. And so it's kind of like a chicken and egg thing with the hemp industry, where nobody's willing to invest in the equipment necessary. And then because there's no demand, but there's no demand because nobody is creating the raw materials in the first place. So that was, I would say, one interesting sourcing journey. And a lot of the research I was doing I ended up finding a lot of really cool products that are from Europe. And that's, a incredibly common thing in the building industry, where there's this amazing new technology or material and it's always not available in Canada or in the United States. It's always in Europe. Like Gramotherm, for example, they make bat insulation, that fluffy insulation between your studs for in between out of grass, sorry. And there's a company that is making pulp fibers, so some of those things that we use in paper, but making it from wheat, but they're only producing it in Hungary and in Germany. And so there were definitely a few different situations like that. The other big issue I had and caused a big delay in my research project was sourcing lignin, which is, like I said, produced in vast quantities at pulp mills, but you can't buy it at a store. So you have to end up talking to these distributors that will only sell you tons at a time. But luckily I was able to find some from Sigma Aldrich. I'm not sure how to pronounce it actually, but this big chemical supplier for research. So that was a big one. And then a lot of those other chemicals, yeah, they're tricky to find. You end up sort of cross-pollinating from different industries. Like I was experimenting with some silicate binders, which again found some interesting results. I'll show you two samples here. So this is another insulation product that's incredibly fire resistant, made from wheat straw. And this one is from hemp hurd. It's very dense and it's got near load-bearing capacity. You could likely modify this very slightly and make load-bearing blocks out of it. And some of those materials I would source from pottery supply locations or even agriculture distributors. So yeah, it's definitely a big part of the fun is trying to source things. Yeah. But thanks
Thanks.
for the question.
Yeah, no, that's great.
Does anyone else have any questions or like curiosities or discussion points? I'm curious now that you've been, oh, Brody, I feel like you've just unmuted. Did you want to?
I was just going to say, I'm going to try to be in touch because I'm also located in the western tip of Lake Ontario. So,
Cool. Yeah, absolutely.
yeah.
Yeah, I'd love to have a chat.
Yep, sounds great.
Yeah, I'll put my email in the chat room, and so anybody who wants to contact me can use that.
Awesome, thank you. Yeah, I was just gonna ask, you've been now kind of out of your studies for just a little bit now. What are you like most excited for now that you've kind of like able to be I don't know, less in the lab and more like in the real world?
Maybe I'll share screens again to explain this. I realize I forgot to talk about it, but I'm launching. We recently got funding from Grain Farmers of Ontario. You can see the icon in the top right, with Evolve Builders, to launch a new materials company called 100 Year Materials. So I was probably a big part of the presentation I should have talked about, but that's what I'm most excited about right now is starting this new company to develop these materials and take it from the lab and from school and turn it into a real business.
That's super exciting. Is like the kind of idea, I mean, first of all, congratulations.
Thank you.
But is the idea that you would be then like a supplier for different building contracts and stuff like that?
Yeah, exactly. So we would be for sure initially just producing to sell in small quantities to contractors and different builders around the Ontario region.
Well, amazing. That's such a beautiful partnership. This is awesome. I wish I knew someone who was building a house so I could hook you up.
Totally. It'll be a few months or a year yet before we're able to sell, but soon enough.
So I'm curious, Garrett, for someone, they'll find this video and they're going to say, I've been doing renos of homes using certain types of materials.
Yep.
And I'm really looking forward to finding a place where I can go to learn about new materials and how to use them. Are there, YouTube videos? Is there a website? Maybe that's what 100, your company is going to have. But if somebody now is interested in learning more about new materials and basically how to use them, because, I have a room to do in my home. It's retrofit. And so every time I've done a room, I've always gone to the latest, materials I could use to get maximum R value. But I don't want to use toxic chemicals anymore.
Yeah, for
And
sure.
so, thinking of if I go to somebody and say, yeah, I know that you've been able to do this. And they're going to say, well, I don't know anything about that. So where can they go to get information and sit down and see, right? if there is something available for them, how they've traditionally looked at a product and how they would look at this product and how they would put it in a home.
Yeah, great question. For sure, there's a lot of YouTube videos on how to build sustainably, and especially for things like if you wanted to do it yourself, like hempcrete, for example, you could totally have a fun project building, insulating a wall with hempcrete. And then beyond that, I would say there's websites like Green Building Advisor that would be excellent for that. And Eco Resource, what are they called? I'm gonna look up the website for just a minute, but there are some there are some, if you search sustainable building materials online, you'll find a lot of that. There's ecohome.net is a good resource for that. And yeah, I would start with a good Google search on YouTube, or reach out to Evolve or a sustainable builder, and I'm sure some of them would be happy just to have a 5-minute conversation with you, even if they're not building your house, just to tell you what materials are better. A lot of people in this industry are passionate about what they're doing and happy to give some of that free labor that other companies might not be willing to do.
Any more questions or just ideas or reflections at all?
Eco Building Resource. Sorry, that's the company I was thinking of saying. So their website is just eco-building.ca. They're a great supplier for a lot of the natural materials in the Ontario region. And I'll be actually hosting a panel with them and 475 building materials. That's another great resource, 475 building materials. And we're going to be 475 high performance building supply, 475 supply. The website is ca.47.supply. And myself, 475, and Eco Building Resource will be hosting a talk at the upcoming Ontario Natural Building Convention, Coalition Convention in April. That's April 13th and 14th, I believe, if anybody's interested in going and learning about sustainable building. It's a great time.
I have one more question actually. So, I mean, I guess you talked a little bit about commercial versus like residential in some of the graphs, but when you're kind of in designing your new company, do you have ambitions for one more than the other? And like, are you thinking about like I'm assuming that like, you know, there is probably higher impact with commercial just because they have maybe like larger buildings. But I mean, I don't know. Yeah. What's the reflections on like commercial versus residential when it comes to like retrofitting initiatives and funding and all that good stuff?
Yeah. I would say initially I would be focused more on the residential scale, and that's for a number of reasons. That commercial projects often need a lot more documentation and hoops to be jumped through for materials approvals. So it's difficult to get materials into large commercial projects. They also often require non-combustible construction, so that immediately discounts a lot of materials, and that's why you often see mineral wool insulation for commercial projects. But that's not to say that all commercial projects are required to be non-combustible, and all commercial projects are won't go out on a limb for materials. It's just more rare. You need like an architect that's motivated to do a little bit more legwork. So initially we would be targeting residential markets. It's easier to break into, and then as things pick up, you kind of expand from there.
Very cool. Yeah, when it comes to those like hoops you spoke about, is that you know, who's creating those hoops? Is it like bylaw enforcement by the municipality? Like, is it something that like could be potentially like worked to be altered, or is it kind of piece by piece? I mean, you talked a little bit about architecture too, so maybe it's more internal.
Yeah, I think there are a few things that go into it. One of them is code and the requirement for Canadian certifications. So there are certification bodies, the CCMC, which is Canada-wide, and the BMEC, which is Ontario specific. Those organizations approve materials for use in buildings, and beyond that, for commercial constructions, I think it often comes down to construction management and internal protocols that require such and such documentation, and they have their go-to typical standards that they don't want to stray from, because they don't want to risk not making as much profit or anything going wrong through lack of information or something like that, lack of familiarity. So those are more of the hoops that I'm talking about.
Awesome,
But a
thank
big
you.
one for anybody that would end up feeling inspired to reach out to building departments or something like that is being more accepting of what's called alternative solutions packages. So there's a way to bypass some of those hoops by submitting an application for an alternative solution to what's approved by code. So there's a bunch of materials that are listed as approved by code, but you can also suggest an alternative and provide some backup information. And sometimes building departments just don't want to do that extra work. So if you ever end up talking to somebody, you can whisper in their ear.
Awesome, thank you. Yeah, I'm just thinking, any last questions or discussions? Because otherwise maybe we'll wrap up early and bid you all adieu, but just want to give that last little moment. Okay, well, thank you so much, Garrett. I mean, everybody in the chat who've already had to leave, already said that they were really thankful for this. I think I speak for everybody that this was really informative and really exciting and inspirational. And I want to thank you for joining us here tonight, and for you know, congratulate you for finishing your studies and also getting your new
Thank you.
deal. So that's really exciting as well.
Yeah.
And yeah, thank you all for joining tonight. It was really great to learn with all of you, and yeah, happy beginning of spring, everybody.
Thank you, Garrett, for coming.
Thanks for having me. Thanks for sticking around, everybody.
Thank you.
Have a good night.